Here's a cute little piece of vintage kit from my travel case with multimeters and related stuff that I take to the repair cafe where I am a volunteer. It's a Japanese-made Sperry Instruments, Hauppauge, New York. Analog meter. Let's get this over here. That works pretty well. I mostly use it for continuity and, basic shorts and resistance tests. I've got it set to ×1 scale. So there's your balancing to zero out the meter at the 0 ohms mark. It's really nice to have an analog meter sometimes for in-circuit things like testing diodes in both directions. Just, reverse the probes and you should get an open in one direction and 10, 15, 20 ohms in the other direction for most diodes. It tells you if it's good, as opposed to a short. Really nice for that kind of thing. Another thing that you can do with an analog meter that I would try if I could easily get into the garage, but I have a damaged foot recovering from a hospital stay, so I can't really go hobbling around looking for parts. But if you apply the meter in an ohms ×1 mode to the primary of a power transformer on a unit that you think might be shorted in the power supply or have a bad transformer, a transformer won't zap up like that real fast on the charge. There'll be a little bit of a slow kick as it starts, and then it'll speed up across the meter. There's a little inductive charge that first fraction of a second when you do that. And once you get used to reading, your basic power cord, fuse, switch through the transformer and back to neutral, once you get used to reading it with an analog meter, you will very quickly be able to tell whether the likelihood is that you have either a shorted transformer or a short, like in the power cord of the switch or something else downstream even on the secondary side that's causing your excess current draw. This seems to work pretty well for DC. I mean, I use it occasionally for batteries. There's the 12-volt DC scale. So here's a 9-volt battery. Now, if I do this the wrong way, if I hook it up with backwards polarity, like that, and the meter kicks backwards, you can, of course, reverse the probes, but this has a minus DC setting, so it reverses the setting of the probes. So I've actually got the battery hooked up backwards, but it's reading as a positive voltage on the, in this case, the 12-volt scale. So we're at about, we were about 9 volts around there. Where here's a 1.5-volt AA battery. And again, I'm using here, I'll switch it back to positive, which means my meter leads are reversed. So let's reverse the meter leads. And there we go on it's the 12-volt scale. So we're closer to 2 volts than 1. So generally good. It has some high voltage ranges that I've never really used. If you switch the lead here to the 1200 volt input, this becomes a 1200 volt AC reading. Otherwise, if you plug in here, it's 600 volts is the maximum. And obviously, because it's analog, you are switching scales, 6 volt, 12 volt, 30 volt, and you have, multipliers by a factor of 10, typically. Same thing on the DC volts. This actually has a 0.3 volt and a 0.06 volt scale. So you still got a common, and you go to the, that would be the 0.6 volt scale. I don't have anything that small, but if you were to use that, you'd be using the scale that ends in a 6 and putting in the the dot and the 0 to make it 06, 06 volts, millivolts. Never really used it for current measurements, but it does have AC amperage. Okay. Using AC and DC, there's a 12 volts, so there must be a special shunt there. Otherwise, for that, otherwise you use the normal volt, ohms, amps plus scale. It's not the handiest thing to read, but I've never really used the current readings, but it does go down to 120 milliamps, I guess. Milli or microamps on that scale. Down here, 60 M. All right, 30 micro, or 30 milli, 12 milli, and all the way up to 600 volts. I didn't look too hard, but I didn't easily find a manual for this online. It would be nice to have one, maybe to figure out how the auxiliary stuff works with the different input jacks, and I have no idea what the output jack is. So again, that's something I'd have to research a little bit. But anyway, handy little meter. I kind of like it. It's higher impedance, you will notice from this, than say a Simpson 260 or something. A lot of the old meters were like 1K per volt impedance, and this one is at DC, and this one is 100K. So a little more useful. We'll take a look inside. I already took the back off. Nicely constructed, uses just two C cells. It's fused to some extent. Would be nice to know if everything's fused or just perhaps the current, ammeter functions are fused. No, I didn't trace it out. Might be just the whole meter is fused. Anyway, nice circuit board, nice contacts, pretty clean. They haven't blackened with age. Let's see, can we see in here at all? No idea what any of the adjustments are for. I'd have to have calibration instructions if I was going to go further. But it's just basically a useful blunt instrument diagnostic tool in most cases. Looking for patterns, things that are missing, or things that are found where they shouldn't be. That's probably the high voltage or high current shunt for AC and or DC. When I was a bench tech, I used occasionally a Simpson 260, but mostly I had a weird looking orange Triplett analog meter on the bench that I don't recall the number of, and I used that thing every day. The meter layout was a little better, easy to read. It had the mirror to eliminate your parallax view angle, and just worked great for diagnostic stuff. Like I said, for checking for shorts, for checking things in circuit. Also good for batteries. This one may be a little less so because it's got a higher input impedance. But when you use a typical analog meter, you'll get something closer to the actual voltage that the battery is capable of producing, because the meter loads it down a little bit like it might if you put it into a flashlight or remote control or some other device that pulls a little bit of current. Anyway, that's about it. I'm sorry I wasn't feeling better. I didn't go pull out a few diodes and transistors and maybe a transformer or two and show you like a few semiconductor tests you can do, even though theoretically it doesn't have a diode test mode. I've never liked those much on digital meters, especially for in-circuit, because they always bounce around. They tend to flop around a lot. And yes, I have a Fluke 87, which is no longer working, and I never liked using that for semiconductors much either. So anyway, that's it. Just a cute little piece if you happen to come across one. It'd be nice to find more information or find a manual on it. Have a good day, and I'm going to go rest my injured and aching foot. Bye.